All right. This is Thomas, Jessica, Jacob, and Maddie, and we're doing our presentation on J.J. Thomson. Yep. So basically, some surface information on Thomson is his name is J.J. He was born December 18th, 1856, and he died August 30th, 1940. He was 83 years old at the time. In 1897, he discovered the electron. And some interesting facts about him is that his son, George Paget Thomson, became a prize-winning physicist, a Nobel Prize-winning physicist, and which he takes after his father, J.J., because he also won the Nobel Prize. And his real name is Joseph John, but people call him J.J. It's his nickname.
So Thomson's experiment was called the cathode ray experiment in 1897, and this experiment proved the existence of negatively charged particles, which we now know as electrons. What he did was he put two plates inside a cathode ray tube that were connected to an electric current, which created a strong electrical field, and then magnets were placed at each end of the tube, which allowed Thomson to use either electrical or magnetic, or even a combination of both, to let the allow the cathode ray to bend. And the amount the cathode ray bent allowed him to calculate the electric to magnetic ratio, which eventually led to the electron.
All right. What did Thomson add to our knowledge of the atom? Well, he discovered the electron, which is a big piece of the atom. He physically performed the experiments. He used the measurements of scattering light, X, beta, and gamma rays to estimate the amount of electrons in an atom. This experiment later led to the development of the mass spectrograph. Thomson's assistant, Francis, furthered the development and led to the discovery of isotopes, atoms of the same element with different atomic weight and a large number of non-radioactive elements. And that right there is the mass spectrometer.
So his model, which I'll explain in a sec, but it's called the plum pudding model, and it consists of these negative corpuscles, which are the electrons, all floating around inside of a positively charged pudding. And now, how it changed from when Dalton discovered it is Thomson discovered the electron, as we all know, and Dalton just said that there was one particle called an atom, and he theorized Thomson theorized that the negatively charged atoms moved around in a positive pudding. And here is our YouTube video.
Thomson had a very interesting academic career. He was one of the people who competed in what they call the Tripos mathematical competition at Cambridge. This is a rather strenuous intellectual exercise in mathematics, and it almost has the flavor of a Harry Potter thing. The winners were referred to as wranglers. So the person who was first place was a special wrangler. Thomson came in second place in the Tripos competition as a second wrangler. It was really quite an accomplishment intellectually. Another interesting aspect of Thomson is that while he is recognized primarily for his physics and the electron and the positive ions in mass spectrometry, he did quite a bit of work before 1890, I think 7 or 98, when he published the work on the electron. And that is totally ignored by people who talk about his life. Considering his birth date, he was in his early 40s when he first started working on the electron, so he was doing a lot of science prior to that. And interestingly, most of it might be considered what today you would call computational chemistry. He was using his mathematical expertise to look into things like the chemical combination of gases and doing the dense mathematics to try and understand that. In that whole experiment, he was also looking into, kind of led to his investigation of ions, both positive and negative ions. And probably the thing that was most interesting at that time was the use of what they call a gas discharge experiment. People had been doing gas discharge experiments for literally centuries prior to Thomson's becoming involved, because they were fun, they were nice demonstrations, they made pretty glowing lights. It was an interesting way of showing that electricity had some weird properties, but it wasn't a very quantitative thing. And so this is where Thomson came in, is he applied some physical concepts to try and discern and make some sense out of what went on in a gas discharge. The gas discharge really is simply creating a volume, a glass volume, and putting a small electrodes at each end and then causing electrical discharge to occur. And this would create ions, both positive and negative, and cause light to be developed inside the glass volume. And in addition, you would end up getting different phenomena as the pressure of the gas and the nature of the gas changed.
Thanks for watching.
Thank you for watching our video.
Yeah.
And everything.
And that's it.